right, we should be live. So, I hope everyone hears me. I see that there seems to be 15 people viewing. I am very new to this. I can say that I've streamed a bit on Twitch before, or rather just tested a little bit. So this is going to be the first time on YouTube. I hope it works out. I guess we have still a couple of minutes until we start. So let's wait a little bit. But yeah, feel free to write something in the chat and just say hi or whatever. It'll be interesting to know who's here. While we wait, can I somehow see who the viewers are, I wonder? No idea. Stream health. Stream is healthy. That's nice. Yeah, also please go ahead and write if you can hear me well, etc., etc. That's obviously quite important. The chat should work, I suppose. Let's see. Hello, chat. Seems to be working. So the plan for today is basically to look a little bit at the development environments I use, how I do programming with OpenFOAM. We're going to look at both Windows. So as you can see, the stream is on Windows now. But we're also going to look at Linux through a virtual machine. And then we'll see what happens. I mean, as I wrote in the announcement, I'm in principle prepared to steer this according to your desires. So please feel free to write in the chat what you want to look at and so on and so forth. The idea of the stream is that this is supposed to be interactive, right? Otherwise, one might as well just record offline. So I sort of expect some kind of feedback from you guys and some kind of interaction between yourselves and me. I think this is what it should all be about. Otherwise, it doesn't make sense to make a stream. You can just make a offline video, right, and upload it. So I'd really like to know, like, if people can see and hear me. That would be excellent if someone just pings in the chat if they can hear me well. Otherwise, it could be pretty stupid if I just sit here and nobody can hear me. It should be working. I did like a test stream before today, so it should be working, but it would be nice to have some confirmation in the chat. And the viewers are piling up. That's nice. I'm not sure how many to expect. I think there was about 50 people who said they want to join in the original post where I sort of proposed this activity. Let's see. We are typing in the YT chat, really? Okay. But I don't see it. That is interesting. Nope. Maybe it's because it's popped out. What if I restore it? Maybe it'll be better. Wonder if you see me. So if I write hi, do you see the hi? Participants. Okay, I'm the only participant in my own person. So it seems like I have my own personal chat here. That's interesting. Toggle time step. Okay, that's just that. Yeah, it seems like I'm alone in my own chat. That's suboptimal. I'm a little scared to click around here in case it just stops sending. Let's see. You're perfectly audible and the screen is visible. Okay, well that's nice at least. But I do really feel like we need to fix the chat because otherwise I cannot really follow what you guys want to do and so on. I wonder what we can do here. Maybe Chandan knows. Well, we also cannot see your chat. Yeah, right. So it seems like the chat is sort of separate from the stream, which is very, very weird. Should we Google that maybe? I don't know. All right, let's Google it. Google stream chat not working. I don't know. I can't chat on live streams. Nothing particularly interesting. And then yeah, so a couple of people are saying that they cannot see, but I am at the right account. I mean, otherwise I would not be able to run the video. Strange. Feedback. Nothing here I can see. Yeah, well, there's two options. Either we just start, but that kind of sucks. I would want chat to work. What if I press edit? Live chat, let's see. Enable live chat. Allow live chat to... What if I disable and then enable it again? That's a bulletproof suggestion. Okay, so now chat is gone. And now enable. Oh, there we go. Now it works. Hi from Hamburg. Yay, it works, guys. All right. So the good old, did you try to turn it off and on again? That's how you fix the chat. I hope at least. Let's let's see. Now I try. At least I see what you wrote before. What if I check participants now? Yeah, now I can see a couple of people at least. So let's see. Test. Yes, I see new stuff also. All right, excellent. Well, great. So I guess we can begin. So I'm going to start with Windows since it's easier. And the main thing which enables working with OpenFOAM on Windows without a big hassle is this Windows Subsystem for Linux. I think that's how it's called. WSL. And in short, basically, it allows you to have a Linux sort of inside a window in Windows. So here it is. You can actually choose the operating system and so on. Let me maybe. How do I do this the best? By the way, no, I'm afraid to touch the chat, but I think I'm going to risk popping it out again so that I can sort of have it on the side. Let's see. There we go. Do it like that. Yeah, so you can actually choose what operating system you install, like which Linux. The easiest, I guess, is Ubuntu because it's so popular. So I have Ubuntu. So basically, it works very easy. So here I am in Windows with my weird desktop, and then I can just click here and bam. It takes a bit of time to load because actually it sources the OpenFOAM bash RC thing, and this is just Linux, so I can write ls or whatever. I can go CD and I can go to my, this has its own sort of file system, and then you can also go to your Windows file system which it's mounted here. So this is just Windows. So it's actually really handy, and you can install OpenFOAM at this Ubuntu, and then you have OpenFOAM. So I can run OpenFOAM, and there we have it. So this is really handy, and this sort of removes most of the need for a virtual machine, at least for me. Let me see. I'm gonna go back to my directory. Is it better than Linux double boot? Well, it's easier. I mean, you see, you just open it up and it's here. And then you can just click the cross and it's dead. No need to reboot, no need to do anything. So it depends. On the other hand, I mean, the only minus with this Linux is that you cannot really fire up anything graphical. Or you sort of can. You can like download X11 for Windows. And then you actually can run graphical applications as well from here, but it sort of sucks. So I would say this is perfect as long as you stay in the terminal, which honestly, when it comes to OpenFOAM, really is a pretty often use case, right? You just want to, yeah, so ParaView, well, I have ParaView on Windows natively, so that's not a problem. Right, so quite a bit of things are just natively on Windows, so you can just run them on Windows, so it's no problem. And since you have access to the Windows file system from here, you can store your cases actually on the Windows file system. So the way, for example, here I have this OpenFOAM folder, right? And I think if I what is it, -L? Yeah, so you see actually it links to MNT users, So this is a folder on the Windows file system. So if I open my file system here, just in Windows, and I go to here, I will have OpenFOAM somewhere, right? Yeah, there it is. And this is the usual stuff, run, cases, etc. So Microsoft really done a good job at making this really seamless. So it's pretty good. I enjoy it quite a lot. And when it comes to programming, well, basically on Windows there, I would say are two regimes. So let's go to software. I think this is some code. And basically the easiest thing is just to use something you can run in the terminal. And I use Vim. So let's say I open some file and Spalding. Let's see, .h. We can open this up and bam, I can edit it, add some stuff to it, whatever, and then close it. You just got to learn how to close Vim, right? But that's the only thing. So that takes you really a long way, honestly. I would say this covers maybe 90% of programming I do goes like this. I added something in Vim real quick, and then I just compile it with wmake, or just run wmake here, and that's pretty much it. I'm gonna cancel it. So for those of you who are on Windows, I would say this is a really nice solution. It works pretty much without any problems. I've never had any. I didn't I've never ran simulations production runs, so to speak, in this way, because I always work on a cluster. So I don't know, in terms of performance, if this is a bit worse than running, let's say, natively on Linux. Maybe there's some kind of small penalty, but there shouldn't be a large penalty, at least. I think it's perfectly doable. Hi Ananda, what about using Nano or gedit? Yeah, I mean, Nano should be perfectly fine. Maybe it's even installed. Yeah, okay, now I have to know how do you exit Nano? It seems like it's Control X. And gedit, it requires a Windows system, right? So this is the issue I mentioned, that you have to either you have to run the X11 under Windows, which is possible. You can download and run it, and then you can run gedit. But otherwise it will complain that it can't find a screen or something. Okay, it's not even installed, but I guess I can try to install it just to see. Install gedit. Okay, a bunch of stuff. Oops. Okay, update. Basically, what I anticipate is that it will say that it doesn't see a screen. Lewis writes, it seems that the penalty was removed and Microsoft moved to WSL2, so the kernel speaks directly to the CPU, not via Windows like WSL1 per se. Okay, I see. So actually, this is WSL1. I know that because prior to the stream, I poked around a bit of what I have, and it recommended for me to upgrade to WSL2. Strongly recommended. But I decided not to touch anything because I wasn't sure what that upgrade would entail in terms of doing something to my existing Ubuntu setup here. So I decided not to touch it. But yeah, everything should basically be better with WSL2. All right, let's see if this now works with the gedit. Yeah, the Greta picture, there's a story behind that. I was forced to... I play some video games with friends, and we have a Discord, and at some point somebody decided that everyone on the Discord has to have a Greta profile picture, so I had to oblige. But hey, I'm in Sweden, right? So I should promote Greta. Many thanks for all your work. Yeah, very, very, very welcome. I hope it can be useful for someone. I just want your take on the similarities, differences, preferences between the major OpenFOAM fork cheers. There are 3 forks, right? Well, 3 major forks. So the one I've almost never used is the foam extend. So I don't have much to say about that fork because I've basically never used it. What I know is that it's the one which is most different from the other 2. The .org and .com are still very similar because the .com, at least up to a very recent time, integrated everything that was done in .org. So it sort of followed it and then added its own stuff. Whereas the foam extend, it lived its own life, and basically a lot of the API and the API, the class structure, etc., it's still the way it was before some major changes in the other forks. So it's become really difficult to actually write a code that works for all of them. So that's basically the reason why I didn't use it that much, because it's sort of its separate thing. But on the other hand, it seems to have like really cool contributions from, well, basically Yasak and his group and some other researchers who were in the foam extend community. I think Holger Marshall works with that fork also quite a bit. Not entirely sure. As for the .com and .org, as I said, .com is sort of .org on steroids a bit because they've implemented just ported most of the stuff that's in the .org. They don't guarantee compatibility though, so it's not necessarily that they're going to keep integrating everything. So that's pretty much my take on the forks. I've used a variety of things. I used to use the .org before the .com even existed, and then recently I've switched more to the .com. Not for any particular reason really, but I'm also a little bit affiliated with it in the sense that I'm in this turbulence modeling committee, which is organized by the .com. So I guess it makes sense that I use it as well. But it's not a must. So if you look at my papers, I think the most recent one is actually done in OpenFOAM 4.1. So that's like an old OpenFOAM, and it is done that way for, well, some reasons. But some other papers are in 1806, for example, etc. So I think one just has to like look what capabilities one wants and then pick depending on that. Let's see if we can launch this gedit. Yeah, so it's as I predicted, cannot open display. So basically this thing doesn't see a screen, right? So you cannot use stuff which require a floating window. Yeah, you're very welcome. If we have Linux, which idea you suggest? I will suggest VS Code, and that's actually the next thing I'm going to show. So with the terminal, things work really well, as long as things are very, well, sort of not too large, I would say. If you get too many files, it becomes a bit difficult without an IDE. And that's the thing here that stands out, is that due to the fact that VS Code comes from Microsoft, they've really done a perfect integration of VS Code with this WSL. So here's how it works. You install VS Code on Windows just as a normal VS Code. You download it, install it as a Windows application. And then you can also launch it from here. And I forgot if you have to install something separate here or if it just sees it anyway. But anyway, it's super easy. So then you can just launch it by writing code and then a period, so it launches it in this directory. Bam. And unlike all other applications that require a window, this will work because this basically launches in Windows. But you get the terminal here. Yeah, you see, currently using WSL1. We strongly recommend upgrading to WSL2 for improved performance. That's what I was. Yeah, but don't show me again. I will do it later, but not during a stream. But the point is that here this looks like, like it's a normal application in Windows, but the terminal I have here is a Linux terminal. So this is exactly the same as this. So I can run like, I don't know, ls, whatever. And here I have all my code. So as you can see, this is like my big wall modeling library. So here it's actually nice to have an IDE. Yeah, this is like a full-fledged IDE. It's really cool. You can do anything you want in here. There is a special folder called .vscode. And here you have some JSON files, which basically represent some settings for the IDE. And you can set these in an interface as well. But for OpenFOAM, you should definitely have this CCPP properties and this include path. This is quite important. So basically, this tells where your header files are for the IDE, and if you prescribe these, then it can find them. So, for example, if I go to, let's say, this file and I have this les model.h, right? It should in principle be able to find it if I say go to declaration or definition. Yeah, definition. So you see, and then it knows where it is, so it pops open les model.h, which is not part of my code, it's just part of OpenFOAM. Greetings from Turkey. Yeah, greetings from Sweden. Thanks for joining. Yeah, so there's a bunch of extensions for this to make it sort of better. I have a couple of installed, which I can probably recommend. So one of them is this remote WSL, which actually enables the whole thing, that you can launch it from this Linux terminal and have this perfect integration. This VS Code icons is pretty cool. If you look back, you can see that there's a different icon for different type of things, like for instance for this git ignore, C++, tests, it's like easier to distinguish things. Then the C++ enables the, it basically parsing the C code, and it knows what is what when it's looking at the files. This is just for CMake. You don't need that for OpenFOAM. Git Graph is pretty nice. It shows you, I can show you, let's see, Git Graph, yeah. It gives you this nice graph of Git commits, etc., etc. It's pretty handy. So basically like a Git log, but visualized. And then the next one I think was Git Lens, and that's this one. And what that does is that if I open a file, let's say, and then I open, where did it go? Wait. Why is it? Why can I not see it? It should be here. Wait. Second remove. So this is the ordinary source control. So it's going to track your changes, etc. So this, it has Git support without any extensions, of course. So like if I edit something, it should pick up on that. Everything is a little bit sluggish. So let's see, I write something and I save it. Yeah, that, oops. Yeah, then it picks it up. So the ordinary source control works fine. But I don't, so what this Git Lens does is just a little bit of an improvement on that. You can like poke at the line and see how, for example, what commits changed this line and things like that. So it's pretty sleek. Not sure why it's not here. Can we get a super fast summary about what you did do until now? The super fast summary is that I did a PhD in Uppsala in Sweden, where I worked on this code and some other stuff. And then I did a postdoc at Chalmers, which is on the west coast of Sweden in Gothenburg. And that's pretty much it. I also worked as an engineer 1 year prior to that. So the really quick summary is that. Yeah, so I guess we shouldn't focus too much on this Git. It doesn't matter that much. But this is basically the idea. So if I have something large that I want to edit and program, I use this one. And that's the idea. So what I also have is VMware, and it should have a nice Ubuntu 64 for us. So this was what I used before. So usually I would just have an Ubuntu machine, which I would fire up and do all the OpenFOAM stuff in there. And I guess now I can be smart. Close this one, and we can sort of resize it like that. Will it work? Maybe not. Maybe that killed it. Let's see if I... Doesn't seem keen on giving us the... Yeah, I want to make some joke about Linux, but I'm not going to. Let's just restart this, I think. Okay, in the end it worked. But okay, let's start over. I wanted to make like a Привет, Олег. So I wanted to make the window such that I have the chat on the right and everything, but it didn't seem keen on resizing to the to the same resolution that I wanted it to. So let's see if I can just have this in full screen. All right. All right. That's, yeah. I think from here it should work. Yeah. There we go. Should I try again to resize one last time? Yes, it works. Okay, amazing. Yes, let's blame VMware. Yeah, but if we can't blame it anymore, it works. I was just too hasty, you know. I should have let it load up and then it would be fine. So yeah, and this is Ubuntu, and as you can imagine, things are very similar here. So obviously, I have some kind of OpenFOAM here, which won't work since I'm not in a case. And of course I have Vim here, right? So I can do Vimming, but you can also have VS Code. So let's go to the same software and we can do exactly the same thing. Boom. So no difference at all, really. No, it's not fish, it's ZSH. Spooty language server, what the hell is that? Yeah, but as you can see, it's pretty much the same thing. So this Visual Studio Code, it's cross-platform. So you can use it both on Linux and on Windows. So that answers the question of what I would recommend for Linux. I would recommend the same thing. I think it works fairly fine. There's still one thing which I can do in this virtual machine which I cannot quite do in Windows, and that is using Docker containers properly. And the only reason why I want to use Docker containers is because for this particular software I want to test that it compiles across a large range of versions of OpenFOAM. So I tested for like OpenFOAM 4, 5, 6, 7, and I should add 8, and then also for the .com version. So obviously I don't want to install all those OpenFOAM versions because that would be a huge mess. But the good thing is that all of them are available as Docker containers, both the .org and the .com. So what I did is I created a small repository. Let's see if I can find it. Do I need to log in? I shouldn't actually. Let me just find, for example, this. No, that was that decision. It was private. But this should be public. Yes. Or was it on GitHub? No, but that's maybe it's either on GitHub or it's here. Yes, it's here. So there's this repository called OpenFOAM Docker, and what I collected here is just the files that install the appropriate Docker containers and then files that run them. So basically it's just a recompilation of what the developers provide, but I just put everything into like one repo. And what I'm doing now is actually condensing all of this to like one start file and one install file for all of these. It's a bit of a work in progress. But the way this works is, let's see now, if I go to opt, I've cloned it somewhere, OpenFOAM Docker. This is basically this repository, but I'm working on it a little bit. And the idea is that you can write start OpenFOAM and then let's say v1806 and bam. So now in this terminal I have OpenFOAM 1806. So let's check. Bloop. Yes, v1806. And when I'm done with it, I can exit and I can, for example, let's try launching 6. Yeah. So now I have OpenFOAM 6 for this is the .org. Bloop. Yes. 6 and then, yeah, version 6. So that is pretty handy if you want to quickly test stuff under different versions. Because you can imagine that installing all of them yourself would be a huge pain, right? So that's the idea here. And the good thing is that with VS Code, I can actually automate compiling my software under these different Docker containers. So what I have is like a small bash script. And as the input, it takes like the version basically, just as a string, like 5.0, for example. And then what it does is that it starts the associated Docker container, and then inside it executes. In the end of the day, it executes all clean and all make. There's like some stuff you have to add additional, like you have to say, depends also a bit on the container if it's from the .org or .com. Like for the .com, it's easier. All you have to do is just to source like a file inside the image, and then you can run whatever you want. So this way I can really quickly test compilation under different versions. And another good thing is that I can associate something which is called VS Code task with running this script. So there's this task.json here, also in the .vs Code. And this allows you to create these tasks. So you name them somehow, whatever, and then you have the command. And the command is then cd to tests, right, to where this compilation script resides. And then I run compilation with the appropriate string for the version. And once I've set this up, I think it's Control-Shift-B. Yeah, Control-Shift-B. And then I can switch between different things. So let's say I want to try to compile on 1706. So burp, now it's compiling. So really handy, and I have one which compiles under all of them. So okay, now it complains about something, which it really shouldn't, but that's not to the point. I'm not going to dwell into that. But the idea is that you can easily compile under different versions. And I was not quite able to set that up in Windows yet. First of all, I think to use Docker in Windows, you have to have this some kind of professional version of Windows, which I don't. I have like an ordinary home version. And it's overall like more difficult. I don't know how WSL interacts with Docker. I never tried. But it overall seems like a bit of a hassle. Like it used to be that Docker Windows sort of installs VirtualBox and orchestrates things through that. So it's like some kind of additional layer which makes things tougher for us. But on Linux, it's very easy. One silly question, what extra advantages Docker provides in comparison to installing different versions separately? Well, it's just that you don't have to install. You just download the container, or basically you just run this install script. You just run the script and it does everything for you. Well, okay, you have to install Docker before that, but that's not a problem. And like also, since everything is containerized, you're not exposed. I mean, your own computer is not exposed to that OpenFOAM version in any way. So you don't have to like I don't know, mess around with your bash RC to load the appropriate version, etc. Could you share your VS Docker setup files? There are none. I mean, there are no Docker setup files. I think there's probably some kind of integration between Docker itself and VS Code. But I'm not using that. So as you can see, I just have a bash script which runs Docker commands. So it's very primitive. So it's just a bash script, and then here I have like docker start, docker exec. So that's it. I'm not doing any, there's no integration. Then the only integration comes in between the script and the VS Code tasks via this tasks.json. So it's here and what the command does. And the command just does cd into this tests, and then it runs the script. So that's about it. Yeah. So it's like, then it just pops up here, whatever it does inside. Then you close it, and that's done. Chanda, are these scripts available open source? Yes, exactly. So this is open. I'm not logged in right now. So you can just go here. They should work. But basically, this is, as I said, just a reuse of what is already provided by the .com and .org versions. So if we go to, let's say, openfoam.com, close, then I want to, let's say, download OpenFOAM, and then I want Windows Docker, interesting, and Docker builds. And then it will tell you how to do this. So it's very similar. You see, they also have like an install OpenFOAM and start OpenFOAM. And they've had this for all the versions, but they sort of exposed, on the website, only the latest version is exposed. But actually, all of the containers are still there. I think they're on Docker Hub. Docker Hub, I think that's what it's called. So if we go to Docker Hub, let's see, I don't think I have a login here, but what if I just search for OpenFOAM? Yeah. So here are all the containers. So this is the plus is the .com. So this is, for example, for 1906. And these are for the .org versions, so like OpenFOAM 7, etc. So all of them are here. So this is actually where you pull the containers from with those scripts. So it's pretty handy. Yeah, that's basically the setup, guys. I don't think I have much else to add regarding the setup. Besides for this, obviously sometimes I just do some coding on the cluster directly, and then it's only terminal and Vim. But pretty much this is it. CNN can add something about Docker. You can actually write and configure your own Docker builds. Yes, so it's very powerful. We use Docker builds in our clusters. Yeah, I remember you were also asking me about the, what is it called? The other one, not the Docker, but the other container technology. I forgot what name. Yeah, it's cool that you got it working. Yeah, I mean, it's really nice that when you don't have like sudo privileges and you don't want to install anything, you don't want to like have a bunch of files, etc., etc. It can be really neat to have like a container. Yes, Singularity, exactly. Thank you. Exactly. I mean, it's cool that you can sort of create your own little environment, which is independent of everything else, where you can have everything precisely the way you want it. And I guess exactly for building the Docker containers, there should be something in VS Code which allows you to do that. I'm pretty sure, but I've never looked because I was never really interested in building my own container. Have you used Docker container for OpenFOAM with the cluster HPC systems? Almost, let's say. I was looking at it. I've used Singularity actually, not Docker. Singularity is supposedly better when you want to run with MPI. So here I only test compilation, right? So I never really actually do any runs. But as I understand, if you want to have like a cross-node MPI, then Docker doesn't work well. But Singularity should work well. I've come quite far with some support from the administrators of one of the clusters I've used, and They've even set up. I think it can be useful if you want to try to set up on your own cluster. They have some instructions on how to. What was it called? Tetralif, right? Tetralif. OpenFOAM singularity. Let's see if this works. Yeah, this. I think, yeah, how to run OpenFOAM with singularity containers. So they discuss quite a bit here. So if anyone is interested, I think. Let's see if I can copy this. Super. Yeah, exactly. So it's as Ananda says. I mean, if you want maybe your students to do something, I think that's also good without them having to set up anything, or you're afraid that they'll screw things up. I think that's a pretty good solution. You just isolate them in the Docker, and or in the singularity, and then well, in the worst case they break something inside the container, but that doesn't matter, right? So containers definitely have some good use. The only difficulty which remains is that if you want to run with MPI, then the MPI in the container has to be exactly the same as the one you have on the cluster, like the version of the MPI. And that can maybe be a little bit of a pain. But I think if administrators of the cluster themselves provide like a bare bone container with the right MPI already pre-installed, which you can grab and then sort of add your own stuff, I think that would be the optimal thing. Yeah, so didn't work for Ananda with the MPI. Yeah, I mean, they cover a little bit here regarding, so I could run following these instructions, I could run with MPI. Yeah, important MPI versions and the singularity container have to match exactly, right? So this is basically what I said. So following these I could run, but I sort of run out of time / enthusiasm to pursue this further, and haven't really returned to it since then. But I think it's something that you should be able to persuade your HPC provider to give you access to some nice container with the right MPI so you can build your own from that. Because I think all of the administrators of a clusters complain that there's just too many versions of OpenFOAM, and we always want the latest version immediately, etc., etc. So there's like 20 OpenFOAMs on the cluster, which is difficult for them to manage and support. So if we could instead just ourselves create containers, easily, without having to install anything on the cluster per se, that I think would be really a game changer. I think that would make things easier for a lot of people. But of course you have to learn this, sort of this new concept. But it's not difficult to work with these, neither Docker nor Singularity, I would say. At least as long as you're just a user. So, I mean, you could have like one guy in your group who figures out how to build the container, and then he just gives the container to everyone else in the group. And it should work pretty well. So I think this might be the future as this evolves. I don't know if it's Docker or Singularity or something else entirely, but I think it will be used. All right, so the question is, what do we want to do next? I think we can hang out for like 45 minutes more or something at least. I have some time. So one idea is to actually try to code something. I've been working on improving post channel. Does anybody know what post channel is? It's like a small utility. If nobody knows, I can explain it, of course. I think, let's see if I can go to SRC here. Some fun post-processing in Parry. Yeah, but that's a bit off topic, isn't it? I think that calls for a separate stream. I would really like to toy around with, what do you call it, ray tracing stuff. It's actually pretty cool. I've spent a lot of time with ray tracing. I can always, and actually Parry is going to release 5.9 pretty soon. With some new features. I think like if you guys like the live stream idea, we can definitely have more streams. And one idea would be to look at 5.9 and what's in there. I think there's some pretty cool stuff coming for the ordinary OpenGL rendering engine. Should improve the way things look quite a bit. But anyway, so post channel is like a small utility which hasn't been changed for like, I don't know, 15 years at least. So it's really in a shitty state. The only place where it's used, I think, is in one tutorial called Channel 395, I think, which is an LES tutorial for channel flow. And I've done a lot of channel flow simulations. And therefore I've been interested in that utility working better. And what I did before is I like wrote my own improved one, which sort of lives separately. But now I contacted the developers of the .com version and asked like, hey, should we maybe just try to import what my improvements into the post channel, which is in the main code? And they were, well, fairly agreeable to that, so I'm sort of working on that. The utility is super easy. It's the only thing it does, like, let's open a channel flow, I guess. Do I have I should have some kind of channel flow. It's impossible that I don't have a channel flow. I've run so many channel flows that it's a little bit embarrassing, really. Let's see. But actually here, I'm not so sure. Let's see. There we go. No .foam file. Maybe here. No. Let's just add one real quick. It's zipped. Then I need to unzip. Let's see. Run channel flow. Oops. Just unzip this real quick. Should do a survey before the stream in the future. Yeah, that makes sense. I mean, I think I'm going to do a survey regarding what to, either what to code or actually just what to have a stream about. I've originally had like no feeling for how interesting this could be to anyone or not. So since there's some interest at least, we can definitely continue and then I can follow what you guys want to do. Hi, how to develop and compile new thermophysical model in OpenFOAM v8. I'm not sure. I've never done compressible flows, so I don't know how to work with thermophysical models, unfortunately. How do we use different material properties within the same domain? Different properties for different regions. I am not sure. So you mean like a multi-region type of simulation, like for what is it called? The heat transfer when you have a solid and a fluid. I haven't really done any of those, I have to say. I've never done multi-region either. When it comes to simulation, my life has always been quite simple, honestly, guys. I use very little modeling since I run LES. I run incompressible flows and I run quite simple flows for the most part. The only thing which was sort of more advanced was during my postdoc where I did multi-phase. So then it was WoW. So that's pretty much what I know in compressible, and I know WoW. I don't know much about compressible flow at all. So yeah, compressible flow is life. It would be nice to learn, really, but so far no opportunity, to be honest. So I have actually no idea how the compressible solvers work in OpenFOAM. What's the idea there? Like how the... Yeah, I mean, I have a basic understanding, but I haven't really looked at them in detail at all. An idea would be to implement a higher discretization for convection. That could maybe be cool. Well, that's not easy though. It's like, I mean, that's the problem. Like, one has to, it depends. Like, one idea would be to have like some sort of project which develops slowly in time, online with the stream. And the other idea is just to look at small stuff from time to time and not have something continuous. Maybe a small script to yield cross-sectional properties for post CFD in 3D. I mean, you can just use the sampling in OpenFOAM for that, right? You don't really need a script, or? Or maybe I'm not entirely reading you correctly here. For further in space. Yeah, I mean, I think it should be fairly easy to do once you settle on some scheme and you understand how it works. Also, if you sort of restrict yourself to hexahedral grids, then it's actually quite easy to do 4-4. I mean, it probably... Well, I mean, it's easy to make some kind of 4-4 stencil, right? Then how well it works is another problem. I don't know, like I'm also a little skeptical, like, to these 4-4 type of things. Maybe it makes sense if you have like shocks, but otherwise you're still second order, right? Since you have finite volumes, so the whole method overall is second order. You can't really do much about that. It's my understanding is that making the interpolation schemes higher order makes sense under very specific circumstances. Barrier features and different tutorials. Yeah, also, yeah, that could be fun. I mean, I would have to prepare a bit to think about what features. I mean, another idea is to look at OpenFOAM tutorials together. Like we can, you know, pick up the. Let me see. What is it? Wiki. Let's see. Yeah, this one. So there's a bunch of tutorials in here, which I haven't looked at much, honestly. And there's probably like stuff here which would be interesting for me, like stuff that I don't know, like let's say compressible flow. That would be fun, like to look at some different topic. I don't know, collections by topic. Yeah, I forget, compressible flows. Okay, there's only one, but that's a start. There's probably something else one can find. So that could be also an idea to just you know, look at tutorials together, try to figure out how things work. But let me show you one channel flow. It wouldn't be a stream by Timothy if channel flow doesn't appear, right? So let's gotta give you the channel flow. This is actually wall modeled. Let's see what's happening here. Something. I'm back, right? Ah, wait, probably there's no mesh. I probably store it with no mesh so it doesn't take up space. This is just from an old study. Yeah, there we go. So you see it's No, actually this is well resolved, but it's a low Reynolds number channel. So yeah, this is channel flow. You have two walls, and then you have periodicity in all the other directions. So like a super canonical turbulent flow. So typically if you do LES, this is what you start off. Like this is your first project will be channel flow. So it's a nice flow because you don't have to care about inflow and outflow. But you do have to care about the walls and all the wall turbulence that follows. So it's a pretty nice flow to test things for wall-bounded turbulence. There's a reason why I and many other people have dedicated so much time to it. It really helps you sort of concentrate on one particular problem, which is the physics of a near wall turbulence. It really sort of isolates it from all the other stuff. So in that sense, it's a really nice flow. And what this post channel does is that it averages your results across the whole plane. So since you have periodicity in X and Z, you can average across the spatial directions to improve your statistics. So what post channel flow does is just it goes for each column of cells, then adds everything up and divides by the number of columns, more or less. Why not start a project that we can all do and learn from each other? Yeah, that would be fun. I mean, I'm up to all type of ideas, really. Absolutely. I think we should. Yeah, I'll probably start some kind of post on LinkedIn, and we can try to decide there. I think there can be room for both. I mean, I don't know how like popular, exciting you guys found this stream, and it's a completely sort of new thing for me. So I don't know how much this is really worth, but I mean it's pretty fun for me. So I could consider like streaming once a week or something like that. Or once in 2 weeks, whatever, but on some kind of regular basis at least. And absolutely, I mean one idea would be to try and do some kind of development together. Could be fun. Another would be to just look at stuff, which is probably easier to some extent, but I don't know what's more fun. Development of a new turbulence model. Yeah, that is fairly doable, I think, as long as we have sort of a model in front of us. New transport, new thermophysical. That would be like a more dive into new stuff for me, the transport and the thermophysical. I mean, the thing is, like, how much are you guys prepared to just see me in front of a computer and like going like, hold on, staring into the OpenFOAM code. It's like that's a thing. Like, if it's something which I don't know how to do, right? That implies that I'm just gonna sit there and figure out how to do it. So it's not gonna be like a very interactive tutorial-ish type of thing. Like this time I've just been sitting and telling you guys how I do stuff, right? So I can just chatter all the time. But if I'm going to do something which sort of out of my comfort zone, then I'm going to have to like sit, and actually do it. So it's not it's a bit of a different type of show. So I don't know, like it's I think there's like pluses and minuses to all type of stuff. Rafik says, my 2 cents of a subject is whatever project you choose to do, it should help people on how to use flow field properties, how algorithm works generally. Yeah, I mean, it could be fun to sort of try to go a bit low level, like one can use OpenFOAM in different stuff, in different ways, right? You can use it really high level, like use the whole machinery for solving equations. When you sort of write div la 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 equals to grad la la la, or you can just use like a very small subset of the library and do everything from scratch. In principle, you can use it like that as well. So then of course you can go to the real basics and just implement almost anything really. Give us tips to make our workflow efficient. I don't know, Ananda, like this, I think it depends. It's like personal preference, right? Like some people, like when I tell them that I use Windows, they want to execute me. Like almost literally. And they say that, yeah, VS Code is like super inefficient because you have to load the GUI. So it's like horrible. You should do everything in Vim, otherwise you're a noob. So it's like, it really depends. I think one has to sort of find, one has to try a bit of different stuff, and in the end you will arrive to something that will be efficient for you. Like I learned quite a bit of Vim, but I'm still bad at it in spite of using it for 7 years, right? I only use the basics. So I'm like okay with having Vim bindings in the VS Code, which by the way is possible, so you can have Vim bindings. And that's enough for me. But some people say, no, you have to do everything in Vim, right? Or everything in Emacs. So it's hard to recommend how to become more efficient. Any free courses to explore other than Wiki, OpenFOAM? Not sure about courses. I think the website for Håkan Nilsson's course at Chalmers is like really popular. Let's see if we can find it. It's Chalmers open source COD. I think this is something like that. Yeah. So it's this website. And you can see like there's proceedings and course links. So there's a bunch of reports by people who've done the course. There's some lecture notes. And then you see, so everybody sort of does it his own project. So you can like look at the report, the slides, and usually the code. So it's actually quite a good place to sort of look for some more obscure stuff, which is maybe not implemented elsewhere. But so usually these reports are kind of tutorial-ish style. That's what I mean. So they can be quite useful. I think that's the idea with this course, that you sort of more or less produce a tutorial. Like, let's just try a random one. Topology optimization of fluids through the continuous adjoint approach. Sounds very advanced. Yeah, so you see, it sort of tells you what to do. CD, make DIRs. It's not a scientific report. It's, well, or maybe it's that as well, perhaps. But usually it's friendly for the new guy who wants to just test things out. So I think this can be also a good place to learn new features and new stuff. Let's open something with it. I think people may tend to ask for coding as to their needs, so it would be nice to delve into subjects which can be helpful to everybody. Yeah, that makes sense. I mean, I guess everyone is in their own area, and so they want maybe to get help and inspiration there. So I agree. I mean, basically the more basic stuff one does, the more people can relate to it, right? OpenFOAM code review starting with SimpleFOAM. Yeah, that could be a possibility, Mosen. I agree. Maybe that exposes how much of it I take for granted and not look into the details. But for sure. Yeah, I mean, I think there were a lot of good ideas, honestly. We have to sort of just pick something for the next one, etc. We can stay with OpenFOAM. We can, like another idea I had is actually looking at different solvers as well. Like I recently had a post on LinkedIn where I linked to like 4 different high order solvers. And it would be cool to try them out just to see how they work, just run some, first look at PyFar or whatever. I would personally be a bit interested in that as well, broaden the horizons a little bit in terms of the codes. Because there's quite a bit out there, honestly, even though OpenFOAM is, of course, the most general purpose. But I think it's good to keep an open mind to see what else is out there. There's this, what is it called? Basilisk, I think. Ananda, I think you should know. There's, or yeah, I think it's called Jerry's, and then the second sort of next iteration is called Basilisk. Anyways, it's like a Cartesian solver, but it's supposedly really cool for multiphase. Actually, I've had multiple people say that it works better for multiphase flow simulations than the VOF solvers in OpenFOAM. So that would be cool to see also. Let's see. You don't want to go there, huh? I'm very suspicious how OpenFOAM goes without a proper density-based solver. Is it without one? I literally have no idea. So like those row variations, are they not proper density-based? I haven't, honestly, as I said, I haven't looked at compressible at all. You've heard of doing super huge simulations in the OpenFOAM platform. Mean number of cores. Yeah. People do. Hattie, people do 1,000 and more. I did 1,000. Works well. We done some testing, like scaling testing, and up to 1,000, it's absolutely no problem. Like, I think we went to 2,000. It was still no problem. I think like it starts becoming crappy when you go maybe into the 10,000 area. I'm not entirely sure, which doesn't stop people from running on those type of huge machines, but I think they maybe run into some problem due to the communications in the, as far as I remember, it's mostly in the CG, conjugate graduate solver, conjugate gradient solver. But I haven't looked myself. I'm also like curious at all the efforts in making some kind of GPU implementation. There's been several iterations, and it seems like now actually NVIDIA is working on one. Sorry. So I guess if anyone can do it, it should be NVIDIA, right? On their own cards. So I'm quite excited to see. They had a presentation at the latest OpenFOAM conference in Berlin, or like in Berlin but online, but I haven't attended that, unfortunately. Because so far it wasn't really, didn't really live up to the hype for GPU, for OpenFOAM at least. Other solvers seem to be ahead. Yeah, I'm not sure about the density-based solver. I mean, there's something compressible, right? But I'm not sure how good they are. The artificial compressibility solver, which is not popular nowadays. Yeah, PyFR is definitely also. I did one thing in PyFR. I did like it was really easy to install, and I could run the first tutorial like with a cylinder. Worked really well, honestly. Like no problem. Super easy to install just from PyPy. Like yeah, no problems at all. So that's definitely a candidate if we want to look at other codes, I think. It could be cool. There's like, yeah, several high order initiatives which are promising. Saw Julia on my machine. Yeah, that's true. I mean, to be honest, I mostly use Julia as a calculator. Like whenever I need to like quickly do something, I just open Julia and like 1 + 1. But it's pretty nice. I like it. I think Julia has a great future, to be honest. It's much more like Python than C++. It's much easier to, well, learn and code in than C++, I would say. C++ seems like an endless journey. You'll never really learn. They develop the language faster than you learn it with the new standards. But the whole idea is that it's fast. Like I did one like serious thing in Julia. I rewrote block mesh in Julia. back in the days, like maybe 5 years ago. And it worked really well. Like it worked as fast as the Blockmesh original. So at least for that particular application, without any super rigorous testing, it worked well, I can say. So that was a bit fun. But I haven't done anything serious. Like Julia is like one of those things which I really want to learn and invest time in, but there's really never a good opportunity somehow. Sorry, guys. Did you use Dakota with OpenFOAM? I did not, but a good friend of mine did. He did. He used Dakota with OpenFOAM, but as far as I remember, not entirely like integrated. But like I think there's some kind of script which orchestrates Dakota and OpenFOAM somehow. Like. Yeah, I haven't done it myself, so I'm not exactly sure. But like the script sort of drives the optimization procedure through Dakota, and then when it's appropriate, it launches OpenFOAM or something like that and runs the simulation. I'm not entirely sure, but it's definitely possible. Another idea, coupled simulations. Right, yeah. I've heard about Precise. It's like a coupling software, which is supposedly very efficient, and it works with OpenFOAM. Yeah, it could be fun to try to do like some kind of simple FSI. I don't know what's like the simplest possible FSI problem, but could be fun. If we use different meshes for two different scales of a simulation, can we interpolate between the scales and have different solvers to cater to different scales? I'm not entirely sure what you mean by that. Can you elaborate a little bit? You mean like two different meshes, so two different simulations? Interpolate between the scales. Yeah, I'm not entirely sure what you mean here. But is Lights open source? I haven't done DM. That would be also completely different. Spring mounted on the cylinder, maybe. Yeah, I would have to learn some kind of mechanics solver for that. But it could be fun for sure. Do you guys have any idea what one would use for like the solid solver? Like I know there's something like, what is it called? The one which comes with Code Saturn. Like Code Saturn is CFD, right? But there's Codeaster. That's the one I know. That's like a open source FEM. Right, Deal 2, yeah. Mm-hmm. Macro scale CFD simulations and mesoscale cellular automation. Okay. But so then you want them to run separately, and then you want to sort of combine the results by some clever interpolation. Is that the idea? This I mean, the idea is not. You can't do things like that, in short. So this is called like multi-fidelity. And actually, the same friend that works with Dakota now works with multi-fidelity, ironically. And yeah, so the idea is, for example, imagine you want to predict like, well, I don't know, the drag of an airfoil with respect to the Reynolds number or whatever. So what you can do is you, for example, do like 5, let's say, LES simulations for 5 flow conditions. And then in between those 5, you do like 10 rants, right? In between each of them, because that's super cheap. And then you can, like in a smart way, using the LES data and the rants data, account for the gap in between your LES simulations. So not just using the rants, but you sort of enhance it with so it's an area of research, I think, on how to do that properly. But yeah, and I think that will actually become big when we're there mathematically, like, or if not real mathematics is probably already there, but we just have to understand how to apply that properly to CFD. So what you're saying sounds very similar to that. So like having simulations on different scales in this case, but I guess to some extent the cellular is like a more accurate representation of its own scale, right? And then the CFD is a more accurate representation of its scale. So then you have to combine somehow. So yeah, I think it's possible, but it's not easy, I guess. You have to really understand how to do that correctly. But it's, I think it's a promising approach altogether. All right, guys. I don't know. What do you say? Should we wrap this one up? We're close to 1.5 hours, which was pretty much my original time frame, in my mind at least, for this one. We haven't done actual programming, so I don't know if I delivered on the promise. But I think this was, you know, like if it's like the pilot episode of a show, right? We just have to sort of see if this works and if this is interesting and whatever. So I think I personally consider this a success. I don't know about you guys. We have to yeah, see how we want to move forward. And I agree to making a poll. And we had some really nice ideas on what to do, I think. Both with other software and yeah, and coding and others. So I think that's totally doable. It's, as I said, what I haven't figured out myself yet is like, if we do programming and a new sort of project, like, I mean, I don't know, like for myself, would it be fun to look at somebody actually sit and code? You know, is that fun to watch? I'm not so sure, honestly. Like, maybe it is, but I know that there are some like Twitch streamers which code. But I'm honestly not sure how entertaining that is if I would sit and do that. But maybe it would be. I don't know. Then of course you can just, you know, I can pop up the stream at 10 a.m. in the morning and just sit and code for a work day and just stream that, right? It's not, in principle, if I don't have to communicate that much or just, you know, read the chat sometimes, it's not a big deal, right? I just sit and do my own thing. But I don't know how fun that is for the other participants, so to speak. Yeah, I think, yeah, some of you think it's nice. Well, yeah, we can try that for sure. I mean, no problem. No problem. Coupled multi-scale runs. Yeah, it sounds like you work with interesting stuff, Harris. All right, yeah. I mean, sure. I mean, I've long wanted to do some programming on my wall modeling library, honestly. Because I haven't worked with it for like a year almost, which is a bit of a shame. It's in decent state, but... all right. You have me convinced, guys. We can do a programming stream with actual me staring at code and being angry at the C++ compiler. Then we can do like Eclipse, the rage moments. Why not? Sounds good. All right. Well, yeah. So I guess we can wrap up. So expect a post on LinkedIn soon with suggestions. And we'll see what you guys want to do most. I think yeah, I have like 3-4 ideas that we have picked up here in the chat, right? So we can just select one of them in the poll on LinkedIn, and we just go ahead with that, I think. I'm not sure entirely when, because, well, as you realize, next week it's sort of Christmas. So I think, well, the poll can come soon, and when we can just sit on that poll until next year, I think. That's the most reasonable estimate, I think, for when to continue. Yeah, I mean, I don't know, there's a week here as well, but yeah, I think probably the best idea is just to wait 2 weeks, and we start season 1 in 2021. All right. So thanks for today, guys. It was really cool to chat with you all. Let's restore the chat. Yeah, it's very energetic, so it's really fun and cool. So hope you all enjoyed, and see you next time, I guess. Bye-bye.